So let's look at some examples. How would we start with talking about a line? So here are coordinate axes, the x-axis, the y-axis, and the z-axis. Let's say you give me 2 points on the line. Let's look at this point, say this is the point 1, 0, 0. And let's say you give me a point over here, which has coordinates, I don't know, -1, 2, and 1. So that means along the x-axis, you're at -1. Along the y-axis, you go out 2 units, and then you go 1 unit up along the z-axis. And we want to describe the line that goes through these 2 points. I'll call this one A, point A, and I'll call this one point B. So there's point B, there's point A, you have their coordinates there. How are we going to describe this line? Well, we can think of the vector R0 to be a vector to describe this point, and that'll just be the vector 1, 0, 0. The question is, what will our direction vector be? Well, we can use this vector that starts at A and goes to B. How will we specify that vector? Well, we give a name to that vector. It's the vector AB. That's when I write AB with the vector hat, that means a vector that starts at A and ends at B. And to find the coordinates for that vector, we just take the coordinates of B minus the coordinates of A. In other words, the first coordinate is -1, and we subtract 1. So we get -2. The second coordinate is 2 minus 0. The third coordinate is 1 minus 0. And AB is this vector. So for this line that goes through the points A and B, it's a line with, I'll call it initial point R0, and with direction vector, in this case AB. That's what we're going to call our V as before. Well, then the line has vector description, or a vector form of the line. R equals exactly R0 plus TV, which you could write as XYZ equals R0, which is 1, 0, 0, plus T times V, which is -2, 2, 1, like that. This here is the vector form for the line going through those 2 points, A and B. What is the parametric form? Well, we just look at the first component. X equals 1 plus -2 times T. Y equals 0 plus 2T. Z equals 0 plus T. And again, here T is any real number. So here's the parametric form of this line. What are the symmetric equations? Well, again, just solve for T here. You get X minus 1 over -2 equals, solving for T, it's Y minus 0 over 2, just Y over 2, equals, well, here Z is already equal to T, just C. Here are the symmetric equations for that line. Let's look at another example. Let's say I take 2 points say here's the point 0, 0, 1. That's on the z-axis. And let's say I have this point here, which is 0, 2, 0. What is the line that contains those 2 points? One thing that should look pretty clear is that that line lies entirely in the YZ plane. How will things look in that case? Well, we could take any one point on the line as our initial point. We'll take this one. r naught to be the vector 0, 0, 1. That's using our initial point 0, 0, 1. We could have taken the other one, but I'm just using this one. And what will we take for our direction vector? Well, it will be the vector from here to here. I'll just draw that as an arrow. Or we could have a vector in the other direction. It really doesn't matter. So I'll take v to be the vector from this point. If I think of this as point A and this as point B, it will be the vector AB. And the coordinates are just 0. 2 minus 0 is 2, and 0 minus 1 is negative 1. This will be our direction vector. So we'll have the vector form of this particular line is just r equals r naught, which is the vector 0, 0, 1, plus t times the direction vector 0, 2, minus 1. And remember, r is just this vector, x, y, z. The parametric form is just x equals 0 plus 0t, which is just x equals 0. Y equals 0 plus 2t. And z equals 1 minus 1 times t. Like that. Here's the parametric form for this line. Remember, t can be any real number. And finally, if we want to get symmetric equations, always remember symmetric equations should give you two equations. Now, normally, if the direction vector has all non-zero entries, those two equations can be written in this nice form where something equals something equals something. But in this case, you'll see you can't solve for t in that first equation. I'm just going to have to leave x equals 0 as one of our symmetric equations. And then if I solve for t in each of the others, in the second equation, t is just y over 2. And in the third equation, t is z minus 1 over negative 1. We get these two equations, which are now separated, and these are the symmetric equations for this line.